Okay, so this section is about acid rain. I'm not going to test you on this, but I think it's good to talk about it anyway. So some fossil fuels, especially coal, have sulfur present in them. And so when the coal burns, the sulfur burns as well, and it forms SO2. If you have actually any combustion of fossil fuel, even a really nice clean fuel like methane, which should just produce carbon dioxide and water, there's nitrogen in the air, and that can react within that combustion to form NO2. So when these things react, we have SO2 reacting with oxygen and water, both of these are present in the atmosphere, forms sulfuric acid in the air. Not good. And NO2 can also react with the oxygen and water in the atmosphere and produce nitric acid. Yes?
Does the water have to be ionized for something? Because I remember when we did our bugs and non-water sessions that to make these, they have to be not, like you can't just take water, oxygen, and sulfur dioxide and make the acid.
You can. If you just mix these together, it will make some acid. So how much it makes is going to depend on, things like equilibrium constants and rate constants and all that stuff that we're so into, right? So this would not be a good way to produce H2SO4. It's not going to be really efficient. But yes, it will just happen in the air. So then you've got this acid forming in the atmosphere, and then it rains, and the acid comes down in the rain, hence the name acid rain. Acid rain is actually a problem that's not evenly distributed over the United States. So the problem's worst in the Northeast, a lot of it because of air currents that are bringing these SO2 and NO2 pollutants from the Midwest and bringing them over to the Northeast. Now, water itself, rainwater, is naturally somewhat acidic because of the carbon dioxide. And we just looked at how that works. Carbon dioxide and water can form carbonic acid. But this carbonic acid is relatively weak, and so rain that's saturated with CO2, which is the most acidic it could be naturally, would have a pH of 5.6. But when this nitric and sulfuric acids get in there, the pH can get below 4.3, and that's a hydrogen ion concentration 20 times higher than pure rainwater. So not so good. What does acid rain do? Well, acids dissolve metals, and they react with carbonates. So metals are kind of important because bridges, railroad lines, cars, lots of things made out of metals, and then acid rain will gradually erode them. Marble, limestone, cement, all of these contain carbonates, and carbonates react with acid. And so here you have two gargoyle-type statues. This one is more exposed to rain than this one, and you can see that its details are pretty much gone. It's just dissolved by the rain. Now, that takes many years to happen, but it happens. And concrete in statues, buildings, sidewalks, etc., the acid rain gradually destroys them. Yes?
So I'm curious, suppose a pigeon poop, and that's like very acidic.
Mm-hmm.
Is it more acidic than acid rain? Or...
That's a good question. Is pigeon poop more acidic than acid rain?
Let's get some analysis.
We could. That's a good question. I don't know. But I think we all know from experience, if you let bird poop sit on your car for a long period of time, then when you go wash it off, it can damage the paint on your car, right? So it probably is having a similar effect. But pigeon poop is less of a problem than rain because there's so much less of it. Yeah. That's true. If it's dehydrated, it wouldn't act as an acid anymore. Yeah. But then when you get it wet, like if it rains on it, so then the rain reactivates the acidity of the pigeon poop. And just go around in circles with that one. Acid rain accumulates in lakes and rivers, which affects aquatic life by lowering the pH. In the Midwest, this is not as much of a problem because the soils there are generally rich in limestone. And so the limestone dissolves and it neutralizes the acid. And so then the lakes do not become acidified. But in the Northeast, where all that smog from the Midwest is blowing, they don't have much limestone around their lakes. And so then those lakes become more acidic. And then we also get trees being affected. When we look at a picture like this, this is the effect of acid rain. And my first instinct is to say, ooh, the acid rain is burning the leaves off, right? That's what I would naturally think. But actually the problem is the acid leaches nutrients from the soil. And so now the soil is poor and the trees don't thrive and they die. So back in 1990, before most of you were born, there were some amendments made to the Clear Air Act that targeted acid rain. And so utilities were forced to lower their SO2 emissions gradually over time. You can't just suddenly say, okay, you can't make SO2 anymore because then the company won't make electricity and then we have some other problems. So they schedule this out. And it's like, okay, by this time you need to meet this deadline, etc. And as we can see from this graph where we're looking at the concentration of SO2 in parts per billion in the air, it's decreased from, looks like maybe 130. Over here in 2016, it looks like it's maybe 17 or so parts per billion SO2. And so the amount of SO2 in the atmosphere is being reduced. That reduces the amount of acid rain. And so then we see that the lakes and the rivers and the soils in the Northeast are beginning to recover from that.